In this session, we will discuss how to remove left recursion from a given grammar. Removal of left recursion will be useful in the conversion of context-free grammar to Greek normal form. Let's start the session. Consider the production rules. A will give you A alpha or beta. It is called as left recursion because we had defined rule for non-terminal A and the same non-terminal is appearing as the first symbol in the right hand side of a production rule. So it is known as left recursion. Now consider beta is B and alpha is A, and we are having A will give you A alpha, that is AA or B. Now it will represent a language L. A can give you B, A can give you AA, and A can be replaced by B, and it will generate B, BA, BAA, and so on. We can denote it by BA star. We can able to write down its right linear grammar, and A will give you, we need to generate a single B, so we will generate B, A dash, and A dash is used to generate A star. So we can say A dash will give you A dash or null. Similarly, for A will give you A alpha or beta, we can able to remove the left recursion. A will give you the production rule which are not starting with A, that is beta, beta A dash. A dash will give you the symbol appearing after A, that is alpha A dash or null. By this way we can able to remove left recursion from the production rule. A will give you A alpha or beta. Now we will discuss why we will need removal of left recursion. Suppose A will give you A or B and we want to process a string W and it is on the input tape. So our read write head is pointing to B and we are not aware about how many A are appearing after B. Whenever we are starting with A, it can be replaced by AA or it can be replaced by A will give you B. Because we are not aware about how many A's are presenting after first B, so we cannot able to determine how many time we will apply A will give you AA. In comparison to that, if we are having the production rule, A will give you beta A dash, A dash will give you A dash or null, and we are having the same string as the input string. So we will replace A by BA dash. The first symbol B is matching and read write head will point to the next symbol. If the next symbol is A, we will replace A by A dash by A dash, and this second symbol A is matching. Now read write head is pointing to the third symbol. If the third symbol is A again, we will replace A dash by A dash and so on. Once we will find out blank on the input tape, we will replace A dash by null and we can able to generate the string W. Now we want to remove left recursion from the grammar. E will give you E plus E or ID. So we had already discussed if A will give you A alpha or beta, we can able to remove left recursion using A will give you beta A dash, that is the production that is not starting with A. We will write down that one, and new non-terminal that is A dash. A dash will give you the symbol after A, that is alpha A dash or null. Now for the production rule, E will give you E plus E or ID. Here E is A, so it is A, alpha is plus E and ID is beta. So we can write down E will give you beta A dash, that is ID, we can write down non-terminal as E dash. E dash will give you alpha, that is plus E dash or null. So this will be the equivalent grammar after removal of left recursion. Now suppose we want to remove left recursion from E will give you E plus T or T. So A will give you A alpha or beta. Here E is A plus T is alpha, T is beta. We can remove left recursion using A will give you beta A dash. A dash will give you alpha A dash or null. So E will give you beta, that is T. T E dash is the new non-terminal. E dash will give you alpha, that is plus T, and the new non-terminal is E dash or null. So this represents the equivalent production rules after removal of left recursion. In the next session, we will discuss few additional problems for removal of left recursion. Thanks for watching this session.